Hi, everyone. Today, what I want to go through is a review of our discussion of rates. And so, this is something that you should have looked at over the last couple years. But I want to do today is just break down what is a rate and then just get us used to kind of using them. So, what you'll see on the screen right now in red is a quick little definition of what a rate is. It's a comparison using different units. So, unlike ratios and proportions, where yesterday we talked about a comparison with the same units, today what we're talking about is comparing two different types of units. And so, I just want to get like a very, very quick list down of some of the common rates that you guys would see every day. Like, for instance, I would bet that if you were to come to school today, like you would have passed this rate probably like 10, 15 times maybe. The idea that for most of you, you would have passed a speed sign and you would have seen like kilometers per hour written on those signs. That is a rate. It compares kilometers with hours in a certain way. I also want us just to be reminded a little bit that what that actually represents is kilometers divided by hours. That per word that you see, or that word that we say when we read a rate out loud, actually means division. Now, there's a number of rates that you guys also encounter that's not just speed. Like maybe if you go driving past Guelph Street and Mountain View, you guys will see like cents per liter on like gas station signs. If you were to go through and talk about bulk food, if you were to go into a store and buy, I don't know, gummy worms or something like that, then maybe you see a number of cents per pound, cents per LB. Maybe you see like a certain amount of dollars per 100 grams because something's really tiny. That we have a number of ways that we can go through and we talk about rates. Rates pop up in our lives daily. We got to make sure that we're comfortable with them. So let's hop in. Let's play around with some problems. Okay, what you'll see on your screen right now is just a quick instruction. I want you to find the indicated rate. What that means is I am telling you what the rate is. So let's take a look at A. You've been told that 5 limes cost $1.30. Find the cost per lime. So when we mention indicated rate, there is your indicated rate. If I would have just left that blank and you were to come up with a rate, then you could come up with different rates for this problem. You could come up with a cost per lime, or you can come up with a lime per cost, in this case, dollars. But because the problem said cost per lime, that means we don't have choice. It's telling us how to calculate it. And if we recall that the word per means divide, the nice thing is it's actually telling us how to calculate it. We need to take our amount of dollars and we need to divide it by the number of limes. And so in this instance then, we're going to take our total cost, which was $1.30. We are going to divide that by 5, and we then come in on a certain way we want to write that. Now, when we calculate that, depending on how we calculate it, we may have different units. Therefore, we may have to express it in different ways. A very common way for us to express that would be exactly as that's calculated, 0.26. Now, what is that 26? It is dollars. So $0.26 per lime. But for a lot of us, when we read that, we would actually read $0.26 to represent cents. And so we could just as easily write 26 cents per lime and we would be correct. There is nothing in the problem that defines what units we need for cost. Okay, just remember a quick thing. If we're talking dollars, dollar sign goes out in front. If we're talking cents, cent symbol comes on at the end. Okay, let's take a look at B. Mary swam 200 meters in 1.2 minutes. Find her speed in meters per second. So, this is where I'm going to say we want to be very, very careful, because we could pretty quickly look and go, oh, there's my indicated rate, meters per second. And so very quickly we say, well, 200 divided by 1.2, because we just get used to like using the numbers in the problem, the given values, and we'll notice that we would be making a mistake in that instance. If I was to calculate 200 divided by 1.2, I would be calculating meters, because that's what the 200 is, and 1.2 is in minutes. Notice you would be calculating meters per minute, but the problem asked for meters per second. So there's nothing wrong with doing that. Nothing wrong with doing that. We just have to make sure that we're finding the indicated rate. So how can we play around with it? Well, if you did calculate the red, then we recognize that when we do that calculation, we're going to end up getting like 166.6666, so 6 repeated. That is going to represent meters per minute. And now what we need to do is we need to take that answer exactly as we have it, and we need to now convert that into seconds. Well, how many seconds do we have in a minute? We have 60. So therefore, what we would have to do then is we would then have to take our 166.6 repeated and divide that by 60 to get our value. That is then going to give us the proper value for us to work through. Now, a little bit of an uglier case, but something that I want us to look at where maybe we do a little bit more work early, and that'll get us a little bit easier work towards the end. If we recognize that we have been asked for meters per second, then let's just find that rate immediately. So we have been dealing with 200 meters. Per means divide, but now I need to divide by my number of seconds. And maybe we can see how many seconds we have if we have 1.2 minutes. So maybe off on the side or beforehand, if I calculate 1.2 of my 60 seconds, since there's 60 seconds in every minute, then that is going to give me my 72. So what I found then is in a minute or 1.2 minutes, I have 72 seconds. And so if I take 200 and I divide it by 72 right off the bat, then I am going to get to my 2.7 repeated meters per second. So you have two different ways to get there. You can either deal with kind of I'm going to calculate the numbers in front of me first and then correct my units to get all the way down to that correct answer in the end. That would be my red solution. Or maybe what we do is we put a little bit of work in early using the green to be able to adjust my units to then be able to go through the blue solution. So, a couple different ways to play around with it. Obviously, we want to be good at both. Your job is to get really good at one and then try to push yourself to improve in the other. Okay, let's see where we go next. Okay, so I've given a pretty decent length word problem, application question thrown at you. So what I want you to do is pause the video, give the problem a read. Okay, we're back. So you've given the problem a read. And you notice that what we're talking about is some Coke that's sold at Walmart versus some Coke that's sold at Food Basics. And the entire problem for us is to be able to answer the question, which is the better value? Now, what I need you guys to know is I understand that there's an awful lot of stuff that can go into better value. That is, like, some people might prefer one store. One of those stores might be closer to you than another one, and so on. There are so many different things that can go into better value. What I need you to understand is when we talk about it in class, what is the better value? All we're looking at is price. We don't care whether you like bottles versus cans or whether you don't. We don't. It's just price. So now we need to tackle this problem. If I could give you a suggestion, what we're going to do is we're going to tackle this problem two different ways. And what I like to do is I like to go through and just put little headings on things. So the first thing I'm going to do is I'm just going to put a little squiggly line down the middle to separate our two solutions. And the first thing I'm going to do is the blue solution on the left. That is, I'm going to compare Walmart, and I'll just use W for them, and Food Basics, I'll put FB. So if I was simply looking at dollar amount, then what I'm going to do is I'm going to calculate my cost per milliliter at each store. Now, there is a couple things, though, that I need to look at. At Walmart, I am buying 6 bottles that have a certain size to them, 710 milliliters each. At Food Basics, I'm talking about 18 cans at a different size, 355 milliliters, that I can't simply say, but I get 6 of them at Walmart and I get 18 of them at Food Basics. Therefore, no. Because they're the different sizes, I have to break them down into the smallest unit possible. I'm going to break them down into milliliters. So I need a quick little calculation. So off on the bottom, I need to find out how many total milliliters do I get at Walmart. So if I multiply my 6 bottles times my 710 milliliters, then that is going to give me 4,260 total milliliters. If I was to calculate at Food Basics that I have 18 cans, but each one of those 18 cans are 355 milliliters, then I actually have a total of 6,390 milliliters at Food Basics. So we can really see now that we are buying packages of different sizes. Okay, let's jump back up to be able to go through and deal with how do we solve the problem. So up in our Walmart case, I am now paying $2.97 for 4,260 milliliters. Now, I can go ahead and I can calculate that, and I'm going to get a really ugly decimal. Like, it is really ugly. I'm going to have to round it off. And if I work away across my calculator screen, I'm going to get 0.000697183, depending on how many calculator screen or how wide your calculator screen is. That number doesn't make a whole lot of sense to me, but if I put units on it, then I'm talking about dollars per milliliter, because that's what's in my fraction, dollars divided by milliliters. Then I get that value. Okay, maybe that number doesn't have much sense to us right now, but it does allow us to compare some things. If I do the same thing now at Food Basics, I'm paying more money, $4.99. However, I'm getting more in quantity. So if I do that same calculation, 4.99 divided by 6,390, then I'm going to get approximately, you see my equal sign with the dot on top, 0.000780907 milliliters. There is my dollars per milliliter. Okay, which one has the better value? Well, for me to talk about better value in this case, I have to look at my units. And right now my units are dollars per milliliter. So if you have to pay something, do you want a lot of dollars per milliliter or do you want few dollars per milliliter? And hopefully we're looking at it and we're saying we want the cheapest price. Well, the cheapest price then is going to be the fewest dollars per milliliter. And so if I go and I compare, well, I have $0 of each, 0.000, and finally I get to a digit where I can compare. I notice that the Walmart's digit in the same place value as the Food Basics digit is a 6 versus a 7. And therefore, my Walmart price is cheaper. So, recall what we said in class. I do not need a big, light, fluffy therefore statement. You can simply just say, Walmart, and you are good. What was the question? Which is the better value? Your answer, Walmart. That should be sufficient for that problem. Okay, I want to quickly go through, though, a different solution. Because there would have been no problem with us saying, yeah, but when I saw Walmart and Food Basics, I don't really like those big, ugly decimals that start off with 0.0000 and deal with really small numbers. We may have wanted to divide the other way. Well, what if you had said that you're going to take the 4,260 milliliters and you're going to divide it by 2.97? In my ratio, or my rate, my division, I am now taking milliliters and I am dividing it by dollars. So I'm going to get a different answer. And in this case, I get like 1,434.34 repeated milliliters per dollar. And actually, because I even wrote that repeated in there, then I didn't round. I need to get rid of that dot on top of the equal sign. If I do the same thing with Food Basics, and I take the 6,390 milliliters and I divide it by the $4.99, then that's going to get me approximately 1,280.561122 milliliters per dollar. Well, I can come up with those two rates. They have their units on. But now I have to ask myself, if I am calculating milliliters per dollar, is the better value a bigger number or a smaller number? Well, if I have milliliters per dollar, then I want to get the most milliliters I can for every dollar that I spend. And so in the purple case, I'm looking for the larger value. Which one has the larger value? Walmart. Therefore, Walmart is our final answer. So keep in mind, a common mistake when we tackle question 2 is we tend to think that, oh, well, I'm looking for the smallest number, or I'm looking for the biggest number. And we have to realize that it's going to depend on what rate are you calculating. Look at the blue solution, the purple solution. I think you guys really like organizing your solution by just putting a quick heading for both. And that way you can do all of your work and your reader can see where your solution comes from. Okay, let's jump into our next problem. So let's take a look at the problem 3. I want you to pause the video right now, give it a read. Okay, and we should be back. So you see Joanne, Fernando, they go on a bicycle trip for 6.5 hours. They cycle at a steady speed and they take one 15-minute break. If they cover a distance of 125 kilometers, how fast were they traveling? So, couple quick things. First off, I would hope that the idea of speed is a good concept that you have some background with, that you're familiar with. A little thing to note on, that for us, there's a little relationship that we have that distance is always equal to speed times time. And if you keep that thing in your back pocket, I think that can help. And it should be a pretty common kind of thought in terms of reasoning. Distance, how far you go, depends on how fast you go, speed, and for how long, time. And so for us then, speed is related to those two other things. That speed is us taking a total distance and dividing it by time. So for us to be able to work our way through this one, we need to now calculate what was the total distance that they traveled and what was the total time that they were traveling at that distance. Now, I threw a little bit of a quirk in here. And it's one for us that's not really a rates problem. It's more of a logical or a reasoning problem. You may write down that they have a total distance of 125 kilometers. And it took a total trip of 6.5 hours. I'm just going to say be very careful. Because the question asked, how fast were they traveling? Then what we're talking about is their traveling speed. And I want you to notice this other piece of information I gave you about them taking a 15-minute break. That meant they were stopped. And so they really weren't traveling for 6.5 hours. They were really traveling for 6.25 hours. Now, you might say, why did I subtract off? Like, I would have a bunch of people that would kind of go, yeah, but 6.5, like minus like 0.15 equals, and we have to be very careful. That what we have in this problem are two different units. We have 6.5, which is in hours, and we have 15, which is in minutes. So as you're trying to decide which one you're going to use, it doesn't matter. That I could have some people that are going to convert 6.5 hours into minutes, but they may find it a little bit easier the other way. So if you were to consider, like, how much of an hour is 15 minutes, we should be good that 15 minutes out of 60 minutes is really 1/4 of an hour. And like you guys know that when we talk about stuff, it's a quarter past. It's 1/4. It's 15 minutes. Well, then the quarter as a decimal is 0.25. And so if I was to take my 6.5 hours and I subtract off my 0.25 for the 15-minute break, then I arrive at 6.25 hours. Now the actual rate part of the problem is pretty easy. How fast were they traveling? Well, if I take those and I divide, I get 20. You're not done the problem until we include our units. 20 what? Kilometers per hour. Why? Because that's what we have on top. You have your kilometers on top and your hours on the bottom. Now, I'm going to just get rid of or put down a little or in here. You could have done this problem the other way I mentioned. You could have said that you have 125 as their total distance, but then you went to calculate your hours. And so each hour has 60 minutes. So if I multiply that by 60, then that's going to get me up to 360 minutes in 6 hours. 0.5 is a half, so a half of an hour is another 30 minutes. Then you have a total of 390 minutes. Oh, but wait a second, we still had that 15-minute break. So now I have to take off my 15 minutes. and we get to there. Now, for some of us, that's not too bad. We maybe don't like it because now when we go through and we calculate, we're going to end up getting like 0.3 repeated. It's an uglier number. Maybe more importantly, when you go through and do that, you have 0.3 repeated, or if we recognize that that's just a fraction 1/3, your units are kilometers per. Now it's minute because you chose to write that bottom number in minutes. As we tackle that, the only reason why I think I would recommend the blue is because it probably makes more sense to you. Like if I told you somebody was traveling at 20 kilometers an hour, you probably have a sense of how fast that is, just from riding in a car and knowing that most cars travel around town at 50 kilometers an hour. And so 20 kilometers an hour can be estimated. If I told you that you were traveling at 1/3 or 0.3 even kilometers per minute, my guess is we really don't have a frame of reference to try to determine whether that was fast or not. Okay, hopefully we're good on 3, and I want to finish off with our last problem. So let's pause the video again, and we'll give that problem a read. Okay, so we've had a chance to read it. Now, I'm going to throw this one into the doozy category. Okay, I think this is a pretty tough problem. I think it's a challenging problem because there is a number of different units in the problem. I think that there's some reasoning for us to be able to work our way through. But also because it probably requires some information that some of you guys don't have at your disposal. So if I was to leave you with this problem and let you go through, my guess would be that there would be one piece of information you would want to know. The problem says that a label on a medicine bottle reads 80 milligrams per milliliter. The doctor's medical reference guide states that the dosage for that medicine should be 20 milligrams per kilogram of body mass. So for every kilogram that person weighs, they should be getting 20 milligrams. How many milliliters of the medicine should be given to a 130-pound patient? And so as you can tell, we have units everywhere. The one piece of information I think you would want to know is how many pounds in a kilogram? And so if we take a peek, there is approximately 2.2 pounds per kilogram. And I think that can help some people out. So what I want you to do is I want you to pause the video now, and I want you to give this one a shot on your own. Come back, and we'll check and see how our solution looks. Okay, but I want you to give this one a shot as best you can. Okay, pause the video now. Okay, and so we're back. So when you take a look at that, then maybe one of the first things I want to do is maybe I want to try to figure out, well, how many kilograms does a 130-pound patient weigh? Well, if there's 2.2 pounds per every kilogram, then I need to take the 130-pound patient, and I need to divide that by 2.2. That will now change that for me into kilograms. And so if I do that division, then that gets me approximately 59.09, roughly, kilograms. Okay, well, now that I know my number of kilograms, maybe what I look to do is to try to come up with my number of milligrams. The question tells me that there is 20 milligrams per kilogram of body mass. And so if I were to then take my number of kilograms and multiply that by 20, then that's going to give me my number of milligrams. And if I push some buttons on that one, then I'm going to get to that. Okay, well, now that I know my number of milligrams, now what I need to come up with is my number of milliliters, because that's what the question asked me for. How many milliliters? Well, it tells me at the very beginning that the label on the medicine bottle reads 80 milligrams per milliliter. So since I have 1,181.8 milligrams, I need to divide that by 80, since there's 80 milligrams per milliliter. And then when I calculate that, I'm going to get approximately 14.77 milliliters. There we go. So maybe you look back on that one and you go, okay, I can see why number 4 was a doozy. There was a lot of stuff to look at there. Okay, similar to yesterday, your job now is to jump in and get as much practice done as you can. So you have that worksheet that we can now fill in those gaps now that we've done a little bit of a rate review. And we should be good at the end of today on all of our ratios and now rates. Okay, good luck.